chemistry class. Let's continue the class error analysis part 2. Before going to learn the new formulas, you just go through the previous video for the formulas of mean, median, mode, range, deviation, relative mean deviation, which we are going to use in problem solving, so you must know them. Okay. Here we have most important and also most familiar formula of error analysis is standard deviation. Yes, it is the square root of the sum of the squares of the difference between the individual value and mean value divided by the number of degrees of freedom. It is used to measure precision. The formula of standard deviation is equal to square root of sigma xi minus x bar whole squared by n minus 1, where xi is individual value, x bar is mean value, and n is number of individuals. And relative standard deviation or coefficient of variation, simply CV. CV is equal to S by x bar into 100, where S is standard deviation and x bar is mean value. We have variance or S squared. The square of standard deviation is called variance. Here the formula is there. Okay. Are you ready to try this problem with our standard formulas? You have to calculate mean, median, range, standard deviation and CV for this data. First thing, you should arrange it in increasing order, then you can draw a table like this. The first column for serial number, second xi, third xi minus x bar, and fourth one is for xi minus x bar whole square. So total number of individuals in this case is equal to n equal to 5. Okay, the xi values are arranged in increasing order. You just sum up them. That is equal to 177.38. Then only you can calculate the mean value. The mean formula is x bar is equal to sigma xi by n. Sigma xi value is 177.38 by n value 5. Okay, so x bar is equal to 35.48. And the second one is median. Median, it is the central value of the data arranged in the increasing order. So already we arranged the data. Central value of the data is 35.48. So the median is 35.48. Then the range calculation. Formula for range is maximum value minus minimum value. The maximum value of this data is 35.49 and the minimum value is 35.46. Just subtract them. The value of range is equal to 0.03. Now you come to the calculation of standard deviation. For the calculation of standard deviation, you need xi minus x bar whole square. So the third column calculation is coming here. You already know the value of x bar is equal to 35.48. For the third column calculation, you subtract the value of x bar from xi and square them. Finally, add all the values of fourth column for sigma xi minus x bar whole square, that is equal to 0.0006. Okay. Now come to this, the formula of standard deviation. S is equal to square root of sigma xi minus x bar whole square divided by n minus 1. So sigma xi minus x bar whole square value is 0.0006 divided by n minus 1. N is equal to 5. So n minus 1 is equal to 4. Square root of 0.00015, and finally S value is 0.01225. And finally, coefficient of variation. CV is equal to S by x bar into 100. S value is 0.01225 divided by 35.48 into 100. So CV is equal to 0.03452. Okay. Let's move into the accuracy. Accuracy is the degree of agreement between the observed value and the true value. 100% accuracy is not always possible. Accuracy is expressed in terms of absolute error capital E. Capital E is equal to xi minus xt. Determination of accuracy using absolute error is not always reliable. So, in the case of single datum in an experiment, accuracy is best expressed in terms of relative error small e. It is defined as the ratio of absolute error and the true value and expressed in PPT. Relative error small e equal to capital E by xt into 1000. Whereas in the case of many data in an experiment, relative mean error in PPT is equal to x bar minus xt divided by xt into 1000. Okay. As I said earlier, 100% accuracy is not always possible, but we can improve the accuracy by some techniques. The following three techniques are working. The first one is the experiment should be carried out in the absence of foreign materials or impurities. Second one is the experiment must be carried out in the absence of determinate error. And the third one is instrument used in the analysis must be checked and calibrated periodically. Okay. Next, precision. It is defined as the concordance or closeness of the results in a series of same experiment. A value is more precise if we get the same value for more than one time. Precision is expressed in terms of mean deviation or relative mean deviation. You know all that formulas. So, smaller the mean deviation, greater will be the precision. Precision is best expressed in terms of standard deviation then mean deviation, because the standard deviation gives the positive results only, whereas the mean deviation gives positive or negative results. Another terms used to measure precision are the range and the coefficient of variation. Next, we can compare the accuracy and precision. Accuracy is the degree of agreement between the measured value and the true value, whereas precision is defined as the concordance or closeness of the results in a series of same experiment. Accuracy is used to express the correctness of the measurements, whereas precision is used to express the reproducibility of the result. Relative error or relative mean error is the measure of accuracy. Here, relative mean deviation or standard deviation is the measure of precision. Precision is always accompanied with accuracy, but a high degree of precision does not guarantee accuracy. Okay, so standard deviation, coefficient of variation, variance, accuracy, and also precision are discussed here. We will meet again. Thank you.